Hi everyone, today we're going to talk about geometric sequences in series. So let's take a look. A geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed non-zero real number. We call this the common ratio. We often use the lowercase letter r to talk about the common ratio. And so we have an easy example here. First term is 1, common ratio is 2. So we go times 2, right? And then each term after that is times 2 as well. And this is a geometric sequence. So the common ratio, why is it called that? Well, just like common difference, the reason we call it a ratio is because if we divide one term by the term that comes before it, notice the plus 1 and then just a sub n down there, right? That is a fraction. That's another way of saying a ratio, right? So common ratio between every two like adjacent terms in a sequence. Okay. So what is our explicit formula for a geometric sequence, right? This is a good one to highlight. You're going to be using this quite a bit. A sub n, the nth term of any geometric sequence, is a sub 1 times r to the n minus 1 power. So similar to arithmetic, where you are taking the first term and then you are adding n minus 1 common differences. Here you are multiplying n minus 1 common ratios, right, to the very first term. So for example, if I want the a sub 7th term, right, I would take the 6th term and I would multiply that by 7 minus 1 r's, right? So from that first term, right, I need to multiply 6 r's in order to get the 7th. Okay, here's an example. Find a sub 5 for a geometric sequence with a sub 1 is negative 2 and r is 4. So we have our explicit formula right here. We want the 5th term, so we take the first term and we are going to multiply it by how many r's? Well, n minus 1 in this case is going to be 4. So 4 to the 4th gives us 256 times negative 2. And I will say, be careful with PEMDAS, folks. Order of operation sounds easy. Really easy place to make a mistake with this concept. Now, the other thing you could do, the long way, right, is you could go from the first term and go, hey, I'm going to multiply by 4. I'm going to multiply by 4. Then I'm going to multiply by 4. And then I'm going to multiply by 4. This works. This gets you the same 5th term in this geometric sequence, right? Except we don't really want to have to sit there and count out every term, especially when the questions could be obnoxious, right? You don't really want to spend time on a quiz or a test doing this for, a sub 100 or whatever the case may be. Okay, example 2. Find a sub n for the geometric sequence. So we have to find the explicit formula for the nth term. So the first thing that's obvious is, hey, we have the first term, right? A sub 1 is 3. Okay, that's good to know. And now the other thing we could find is r. So if we take the second term, divide it by the first term, right? This becomes, you could multiply to get rid of the fraction, right? Multiply the 3 up and becomes 1/3, right? And you get negative 9 over 12, which reduces to negative 3/4. And so now I can put these two pieces of info together. And now again, be careful with PEMDAS, folks. You cannot multiply the 3 and the negative 3/4 and say, oh, this is negative 9/4 to the n minus 1 power. This is not how you multiply exponents. Or excuse me, multiply exponents. That was right. Multiply terms with exponents when the bases are different, right? This only works when the bases are the same. So if this was also to the n minus 1 power, then you could multiply the bases. But that is not the case here. Okay, so we leave that one as is. Okay, example 3, find a sub 1 given the third term is 5 and the 8th term is 1 over 625. And so we've done questions like this with arithmetic. And so the idea here, right, is, okay, to go from the third to the 8th term, how many common ratios would I multiply? So 1 to get a sub 4, another one to get a sub 5, another one to get a sub 6, another one to get a sub 7, another one to get a sub 8. So that is a total of 5 r's to go from the third term to the eighth term, right? And so I can say r to the 8 minus 3, the fifth power, right, is going to equal my a sub 8 over a sub 3. And so we can simplify this a little bit, right? And now what is the fifth root of 1 over 3,125? Well, if you know your powers of 5, right, 525, 125, 625, 3125, right? And so we just get 1/5 for our r value. And now we can use that to get our a sub 1 value using that and the explicit formula for a sub n. So I'm just going to use my third term. A sub 5 is 3. I know the r value, right? 1/5 squared is 1/25. Multiply that over, and so we get a sub 1 is 125. Okay, and so that's all we really needed to find was a sub 1. Okay, now let's talk about a geometric series. So this is the sum of the first n terms of a geometric sequence. So S sub n equals a sub 1 times 1 minus r to the n, okay, all over 1 minus r. Now, the only time this formula doesn't work is when r equals 1, right? Because if you think about it, if r is equal to 1, every term in the geometric sequence would be the same, right? So we really wouldn't want to add those up because it would be infinite. Oh, sorry, I guess that's for infinite. This is finite, so we don't need to really worry about infinite yet. We'll come back to that some other time. But that's our formula that we definitely need to know. Okay, example 4. Find the sum of the first 5 terms of the geometric sequence where the initial term is 12, so that's my a sub 1. And we are told that the common ratio is -1/3. So you could write out all 5 terms and add them up. That seems like the hard way of doing it. Let's apply the formula because we're told everything that we need. So we know the first term is 12. We know that r is -1/3. In the denominator, we can go ahead and make that a double negative. That becomes a plus, right? And so we can combine those. Be careful with the numerator. Again, PEMDAS, you have to do this thing to the 5th power first. 3 to the 5th power, so powers of 3, 3, 9, 27, 81, 243. And that does become another double negative, so we will add. Okay, and so this is 243 over 243. Add 1 to that. That's where the 244 comes from. 1 plus 1/3 gives us the 4/3. And now we're just simplifying. So let's see, 12 over 243, we know they're both divisible by 3. So that becomes 4 and 81. 4 times 244, and so, you know, we talked about this the other day. I like to break this down. 4 times 2, well, I should say 4 times 200 is 800. 4 times 40 is 160. 4 times 4 is 16. So 800 plus 160 plus 16 is where 976 comes from. And now dividing by 4/3 means I'm going to multiply by the reciprocal there, right? And so you can, simplify some stuff here, right? You guys know how to cancel things. 244 over 27. Okay, last one, we have sigma notation, right? So again, here's my a sub 1 times r to the n minus 1 power. Now the difference here is instead of n minus 1, it just says I. Ultimately, it's the same thing, right? But where it does matter is that your first term here, right? This doesn't become 1 minus 1, right? This is just to the first power. So my first term is just 20. And now we're going to multiply by 5, etc., etc. I really wouldn't encourage that, okay, right? But I would write just, straight to the sum of the first 8 terms, a sub 1 times 1 minus r to the n over 1 minus r. And this answer is a little big for a no-calc question, I would say, but you could figure it out if push came to shove. So I really wouldn't recommend writing out more terms of this. Okay. All right, and that is all we got. So I will see you guys next time.